Now here is another question based on homogeneous differential equations. We are given that 1 plus e raised to x upon y times dx plus e raised to x upon y into 1 minus x by y whole into dy equal to 0. Now here, although we can write dy by dx equal to some function by readjusting the terms and then collecting the required terms on one side, but here we are observing the term x upon y at 3 places, correct? So that means if we go by the idea of writing dy by dx as some function f of two variables x and y, it won't be a homogeneous function in the exactly way we want, because since we have x by y terms, but if you observe the definition of homogeneous function was we should be able to write that as some constant lambda raised to some natural number n into the function of y upon x, not x upon y. So therefore if that is the case, then it means that our original premise is not correct, it's to be changed. That means instead of dy by dx we should try for dx by dy, and whatever we want to get, that should be a homogeneous function. Alright, so that's the first clue to how do we proceed to solve this particular equation. So let's try to rearrange the terms in order to get dx by dy. Now we can retain the first term on left hand side and we can transfer the second term on right hand side, so that inside the bracket the sign can get changed. So therefore let us write it as 1 plus e raised to x by y dx is equal to e raised to x by y. Now inside the bracket I can change the sign, that is x by y minus 1 whole into dy. So therefore this gives us dx by dy is equal to e raised to x by y upon x by y minus 1 whole upon 1 plus e raised to x by y. So now the right hand side can be thought of purely consisting of some function of x by y, and of course here we see that lambda raised to n. So therefore in short we can think now of the right hand side as some homogeneous function, right? So if we remember, in the last type we had substituted y equal to vx. So therefore here by analogy we will have to put x equal to v into y, correct? Because we have dx by dy and not dy by dx. So therefore let us substitute that and solve further. So we say that let x be replaced with vy. So we must differentiate both sides now with respect to y and not x. So therefore we have dx by dy is equal to v plus y dv by dy. So therefore on substituting we get v plus y dv by dy is equal to e raised to v, because now if x is v by y, v into y, then x upon y will be equal to nothing but v. So we have e raised to v into v minus 1 whole upon 1 plus e raised to v. Okay. Now we have one term v sitting on the left hand side, so let us bring it to right hand side, right? So therefore we can write y dv by dy to be equal to e raised to v into v minus 1 upon 1 plus e raised to v minus v. So let us expand the bracket and cross multiply to simplify it. We see that the term v into e raised to v will get cancelled, and in the remaining two terms, taking minus sign out, we have e raised to v plus v, and denominator I can rewrite as e raised to v plus 1, and on left hand side we have y dv by dy. Now if you see, it is not difficult to separate the terms. We can write e raised to v plus 1 upon e raised to v plus v on left hand side into dv is equal to, on right hand side we have 1 upon y dy, correct? Now the next step is integration, so let's integrate both sides. On left hand side we see that the numerator is clearly the derivative of denominator, so therefore we have log of e raised to v plus v is equal to log of y plus log c. So therefore we have e raised to v plus v is equal to cy. And finally let us replace v with x by y. So we have e raised to x by y plus x upon y is equal to cy. If you want, we can multiply throughout by y, and we will get y e raised to x by y plus x is equal to c into y square. So therefore that's the solution of the given differential equation. So the important point to keep in mind is, while solving the homogeneous differential equations, we should understand whether it is of the type dx by dy equal to a homogeneous function or dy by dx equal to a homogeneous function, and based on that we use the correct substitution.